This is Lego Man. He is just waking up. Today is a very special day. Lego Man will be taking his driving test to get his driving license.
Lego Man needs to know what his mass is for his driver's license. Mass is how much stuff you have in you. How much stuff determines how heavy or light you are. For example, a feather would have a small mass because there's not so much stuff in it. So Lego Man goes onto a balance to see what his mass is for his driver's license. He's 3.57 grams. That's great. Now Lego Man can put that on his driver's license. Grams can be converted into kilograms, which is the official scientific unit for mass. Before setting off, Lego Man has a present from his mom since he is getting his driver's license today. He wants to put this in his trunk. He exerts a force when he closes the trunk. A force is a push or a pull on an object. He pushes on the trunk of his car to close it before getting in his car. Lego Man is now at the DMV where he will get his driver's license. This is his cool car. Lego Man is about to start his test. After turning on the engine, Lego Man is going to pull out of his parking space after putting on his seatbelt, of course. In order for him to move, he needs to accelerate. Acceleration is how much your speed changes in a set amount of time. Right now, he is not moving, so his acceleration is 0. Now, as he starts the car and starts pressing the gas to go, his acceleration is more than 0. If he starts his car with his acceleration at 0, then zooms off, stepping on the gas, his acceleration would be a fast acceleration. But he started his car and started slowly to pick up speed, so he has a slow acceleration. Let's go back to when Lego Man's car was not moving. His acceleration was at 0 and his car was at rest. Having your acceleration at 0 is also called being at static equilibrium. Now that Lego Man is going at speed limit, his speed is staying the same. Going at the same speed for a long period of time is called going at a constant velocity. Going at a constant velocity also means that your acceleration is 0 because you are not going any farther over time, but staying at the same speed. But this would not be static equilibrium because you are still moving. So when you are going at a constant velocity and your acceleration is 0, we call this kinetic equilibrium. Lego Man has completed his driving test. He now has a driver's license. Congrats! Because Lego Man's parents were very proud of him, they gave him his dad's old car. This is his new car.
Lego Man decides to take his new car for a spin. Unfortunately, Lego Man accidentally runs over his friend with his car. Lego Man had been going at top speed. However, after he hit his friend, his speed decreased and the car came to a stop. This brings us to Newton's first law. This law states if there is no force, there is no change. In this case, Lego Man's friend was the force, and the resulting change due to the force was the car coming to a stop. If Lego Man's friend had not been in the way, Lego Man's car would have kept moving. After running over his friend, Lego Man helps him into his car and rushes him to the hospital. However, Lego Man is no longer able to drive at top speed. This brings us to Newton's second law. This law states that force is equal to the mass of an object times its acceleration. By putting his friend in the car, Lego Man added mass. Since there is now more mass, more force needs to be applied to get the same acceleration as before. Unfortunately, Lego Man is unable to apply the new needed amount of force and cannot drive as fast as before. After Lego Man's friend recovers from his injuries, Lego Man goes to visit him in his hospital room to apologize. However, Lego Man's friend is still upset. He and Lego Man get into an argument and his friend pushes him. But even though Lego Man's friend did the pushing, he still falls to the ground. This brings us to Newton's third law. This law states that for every force, there is an equal force in the opposite direction. Therefore, when Lego Man's friend pushed Lego Man applied an equal amount of force on his friend. Since he and his friend are the same mass, this amount of force affects them the same way. They both fall.
recovering from his fight with his friend, decided to go for a run. It is a very sunny day, and he doesn't see the sign warning him about the cliff in front of him or the very edge of the cliff. So he continues running and ends up falling off the cliff. After he runs off the cliff, the force of gravity or weight takes over, and he falls into the frozen river and breaks some of the ice. Weight is a special force caused by the pull of the earth on all objects towards itself. Weight takes over and there is no surface supporting Lego Man, and he is pulled towards the earth. It is a special force because it is always in the direction towards the earth. Suddenly, after Lego Man falls in the water, he sees a rope drop down to the surface of the water. So he ties it around his waist, and a helpful bystander starts to pull him to solid ice. The man pulling the rope pulls Lego Man all the way to the surface of the ice. Tension is the force along the rope. Tension is a force that goes along a string, rope, or wire when forces are pulling at it from both ends. Tension always goes along the length of the rope or string. Tension is caused by the strain on the rope or the tightness that occurs when forces pull at it. Once Lego Man is out of the water, he is extremely cold. So, he quickly thanks the man and starts running home to change. However, after he starts to run, he slips and falls. He doesn't understand, so he tries again, but ends up slipping again. He carefully walks to the edge of the ice, and he stands there for a while, and then decides to skateboard. He starts skateboarding at a constant velocity. Static friction is the friction applied when an object is not moving. Even the object may not be moving, friction is pulling on it. Kinetic friction is the force of friction acting on a moving object at constant velocity. In both situations, the force of friction equals the applied force, but one is at rest and one is moving at constant velocity. For example, when he is thinking of going back to his house, static friction is applied, and he is traveling. Also, when he is traveling at constant velocity, kinetic friction is at work. There is also such thing as the coefficient of friction, the roughness of objects sliding against one another. This is the coefficient of friction. For example, the skateboard wheels on the ground has a coefficient of friction. Lego Man decides he is not in the mood for skateboarding anymore and gets off. He walks for a little while. To pick up the road that he was running on before his fall, he takes a road that you could describe as a ramp or an incline. He gets back up and quickly runs home to change. Normal force is the force of a surface pushing up on an object resting on it. Normal force is always in the opposite direction that where the surface runs. So if a surface is horizontal, then the normal force will be vertical. And if the surface is on an incline or where the ground curves up or down, such as a ramp, then the normal force is opposite of it, so that it will point in the opposite direction of the incline. Or in shorter terms, the normal force is perpendicular to the surface. We mass Lego Man on a balance, and he had a certain amount of mass in grams. We can convert that to kilograms. However, Lego Man also has a weight, which is entirely something different. Mass is the amount of stuff an object has. However, weight is basically gravitational force. Weight is the amount of force the Earth pulls down on an object with. Mass is not related to the Earth's pull in any way. Here we're going to convert Lego Man's mass into his weight.
There is this one where it goes way. This is the line.
This is Lego Man's mass in kilograms. We multiply it by 9.8, which is gravitational force, which will get us Lego Man's weight. His weight is 0.039 newtons.